So I can't be there with you tonight, but I'm leaving this video lesson for you to try to make it an easier time of actually getting through everything in lesson 2. We started out the last couple of days talking about lesson 1 with just temperature and kinetic energy, potential energy. We looked a little bit at just how you can measure this stuff with 2 different types of measuring with Celsius and Kelvin scale. And now today we're going to move on to lesson 2. So if you have not yet finished lesson 1 work, just make sure you get that done too. But we're now going to look at heat. So this is just like a couple things. Words you probably know, words you're a little bit familiar with, but you may not be totally sure about what these things mean. So to start out here, it just says, when do we use or hear the word heat, and what do you think the word heat actually means? So take a minute, pause the video, think about these things, and just write something down for where we might hear the word heat and what we think that word heat actually means, and then we'll actually see it. Okay, so if you have an answer for these questions, let's move on. You probably hear the word heat just in terms of cooking, maybe just temperature outside when it gets hot in the summer or the winter. And depending on what the temperature is a little heat or a lot of heat, maybe coming off something like a radiator, a fireplace, or a car heater. And we'll see right now what that word actually means for us. So as we saw a day or two ago, depending when you had your test, when you last did this, the word temperature just for us means that it's a measure of average kinetic energy. So if anytime you hear that word temperature, I just want you to be thinking average kinetic energy. It may not happen right now, but as you're going through this chapter, as we start doing more of this stuff, I just want that eventually to get in your head where when you hear temperature, those are the 3 words you think. And if you see the words average kinetic energy written somewhere, you automatically go, oh, okay, I know that's temperature. I remember that means temperature. So when you measure the temperature of something, you're really just measuring how fast its particles are moving. Remember, kinetic energy is the energy of motion. So something with a hot temperature, a high temperature, means its particles are moving pretty fast. They're not just sitting in one place. They're vibrating around. They're maybe moving past each other. They're trying to get out somewhere. They're moving really quickly. Something with a lower temperature is going to be moving a lot slower. Its particles are not going to have as much motion, not going to have as much energy. So that's what temperature is. Well, what about the heat we saw a second ago for the title of this lesson? Heat is a little bit different. And heat's now going to just be the movement of energy due to differences in temperature. So temperature is telling us how much energy something has, and heat is where energy moves between 2 materials because they have different temperatures. So go-to example I always use is a plate of hot food. If you take food out of the oven, out of the microwave, whatever, you put hot food down the table, and then let's say you get distracted. The phone rings, somebody knocks the door, something, somebody says something to you. You get distracted, you come back 5-10 minutes later, your food's not going to be as hot as it was when you started out. It will have gotten at least a little bit cooler probably because the heat in your food went out into the surrounding air, it went into the room. It got a little bit cooler by giving heat energy away to other stuff. So questions like this and situations like this are always pretty easy to see how it works and how it happens because heat's always going to move from a higher temperature to a lower temperature. So if you have 2 things, let's say you have the hot food sitting in the room, if you know that that food is at whatever, let's say 70 degrees, and the room is only at 60 degrees, well, you can pretty easily measure which one's hotter, which one's colder, and then know which direction the stuff's going to move in. So if you know what things have what temperatures, you can always tell which way the heat energy is going to move because you just go from whichever's hotter to whichever's colder. And we'll do a couple of examples together now. We'll just draw some quick little very basic pictures, and then we're just going to draw some arrows. I know this one's this higher temperature. I know this thing's this lower temperature. So heat's going to move from the hotter thing to the colder thing. And now, just as a point, I just use those words hot and cold. It doesn't even have to be a matter of hot and cold. It could be something like 95 degrees compared to 94 degrees. As long as there's any difference in temperature, the warmer one will give heat energy to the even slightly colder one. So in this picture here on the left, we've got a flask of some kind, and it says in the middle that the inside of it, the surroundings, or the middle is hotter than the surroundings. So whatever's in that flask could be just hot water. It's hotter than the room. So the flask will give heat away and heat energy will leave to go into the room. The stuff that's in that flask will start to get a little bit cooler as it loses energy, and the outside surroundings, the air in the room, will start to get at least a little bit hotter because you're going to pick up that extra energy. In the second picture on the right, now it says that the inside is cooler than the surroundings. So that could just be cold water in a moderately hot room. The cold water in the inside will gain heat energy from the surrounding room. The inside will get a little bit warmer as it's gaining energy, and the outside air will get a little bit cooler as it's losing heat energy. So it's just a matter of seeing where your temperatures are and knowing which direction stuff's going to go. But it's always going to move from hotter temperatures to cooler temperatures. example questions on your paper. I'm looking at my own copy right now, and we're going to go through at least one or two of these, probably not every one, and then I'll leave you to do the last one by yourselves. Think about it a little bit, and we'll wrap it up with a couple of quick little vocab words to finish everything off, because I'm looking at the clock and I've got about 10 minutes till the bell rings, and you all show up on Thursday afternoon to take your test. So let's see if we can get through this pretty quickly here. First example on your paper says, an ice cube with a temperature of -2 degrees Celsius, that seems pretty cold, falls out of the freezer and sits on the floor of a room with a temperature of 72 degrees Celsius. And now we just want to draw, it says simple, all capitalized words, so we're going to stress that, simple diagram of this situation and use arrows to show which way the heat will move. So let's just draw exactly what it says. It says an ice cube with a temperature of -2 degrees Celsius. So it's a little colder than the freezing point of water, so it's going to still be frozen. It's going to be an ice cube. So I'm going to just draw myself a quick little ice cube here. Nothing fancy. There's my ice cube. And it says it's at -2 degrees. I'm going to write that right here. There we go. -2 degrees Celsius for this ice cube. Falls out of the freezer and sits on the floor in a room with a temperature of just positive 72 degrees Celsius. So there's my ice cube on the floor, and the room temperature around it is just a fairly comfortable 72 degrees Celsius. It's a nice warm room, and we just now want to figure out which way this heat energy is going to go. So we just need to compare our temperatures. So all we got to do, just look at your temperatures and see which one's warmer, which one's cooler. Heat energy is always going to move from the warmer one to the cooler one. So which temperature is higher, 72 degrees or 2 degrees? Obviously the 72 degrees is warmer, so the heat energy is going to go from the warmer air into the ice cube. So the air in the room that was 72 degrees will lose some heat energy and give it to the ice cube. That's why ice melts if it's in a warmer room. It starts to absorb heat energy from its surroundings. So the ice cube is going to absorb the energy. Write that right here. It absorbs or gains energy, and its temperature is going to go up. Now this may only be a little bit. Maybe it only goes up to about 0 degrees, just enough to melt. Maybe it goes up to 1 or 2 degrees. It's not going to probably be too warm, but it will gain some energy, and that's going to make its temperature increase. So I wrote there, temp with an upwards going arrow. The room, the air surrounding the ice cube now, is losing energy. It's giving energy to the ice cube. So because the air is losing heat energy, its temperature is going to drop a little bit. So its temp will go down as it loses energy. And at some point they'll reach equilibrium. They'll reach a point in the middle where their temperature is even. That may just be, that the ice cube, the water melts and then heats up to about, somewhere in the middle, somewhere in the 60-degree range. Could be the room temperature drops at the same point, but at some point they will get to the same temperature, and they're going to just have, again, what we call room temperature. And we use that phrase room temperature, it means exactly that. The water will be at the same temperature as the rest of the room. So that's how we do this one. Let's take a look at the next one. Similar situation. It says a plate of food at 64 degrees Celsius is sitting on a table in a room that is 49 degrees Celsius. So it's kind of like what I mentioned before, hot food going into another room. A plate of food at 64 degrees sits on a table in a room that's 49 degrees. And again, just want you to draw a simple diagram of this situation. Use arrows to show which way the heat will move. So same level of complexity of drawing before. I drew a quick little cube for my ice cube. And this one you can just draw a circle and draw a box, whatever. There's something just to represent the food. Write a number next to it with its temperature, write a number outside it for the room, and then just figure out which way the heat's going to move. See which one's going to be the warmer temperature, either 64 or 49. See which way the heat's going to move. It always goes from the warmer thing to the cooler thing. So will it go from the food at 64 out into the room at 49, or will it go from the room at 49, the air down into the food at 64? See what you think, draw yourself a picture, answer that, and then we'll move on to number 3. Last of our drawing questions. In a laboratory where the air temperature is 22 degrees Celsius, a steel cylinder at 100 degrees Celsius is submerged in a sample of water at 40 degrees Celsius. So let's look at that again. In a lab where the air temperature is 22 degrees, so the air in the room is 22 degrees, you have a piece of metal, a steel cylinder, a cylinder being like a Pringles can or a tennis ball can, some kind of shape like that, made of metal. It's going to be at 100 degrees Celsius. And it says it's submerged in a sample of water. So it's just in water. It's covered in water. It's, maybe in a fish tank, something like that. It's covered in some kind of water, and the water is at 40 degrees Celsius to start out at least. So if we have that situation, now just draw a simple diagram for yourself. So just draw the piece of metal. You can draw a little rectangle. It's at 100 degrees. It's covered up in water. The water is at 40 degrees. And then the surrounding air in the room is 22 degrees. Once you have your diagram, again, just use arrows to show which way the heat will move. Go back and check which direction heat always moves, from what to what, and just go slowly. There may be more than one thing going on in this picture. So figure out what your picture is going to look like, draw your arrows, and then we'll finish up with some quick vocab words. Your pictures look good. Hopefully it's making sense. There's a couple things going on here. So we've seen some energy being gained, energy being lost. There's always something happening with this heat. Heat's got to move one direction based on temperature changes, and we can kind of classify this as one type of movement or another. What we call endothermic processes are what happens when heat is going to be absorbed. So in that one picture before with the different liquids in the flasks, if the inside stuff is cooler than the outside stuff, then the outside environment will give heat inward to the material in the flask. So anything where heat is being absorbed, much like the ice cube gaining heat energy from the air in the room, that's going to be called endothermic. Endothermic processes are just anything that happens, any kind of process, any kind of change that happens where something is absorbing heat energy. So endothermic is where you absorb energy, and because of that, as heat's moving in, the temperature of this material, of this substance, will go up. The temperature will increase. So if this material right here, this little pink box, was colder than the room it was in, the outside heat energy will move in, and the pink material, the box itself, will actually get warmer. It'll gain heat, its temperature will go up, and we call that endothermic. Endo sounds kind of like into, if you're going to think of it that way. But its temperature will go up. The surroundings, as it says right here, will get cooler. So just in terms of the material itself in the middle, that's what's going to be endothermic. Its temperature will increase. It will gain energy, whereas the outside surroundings of the room, they're doing the opposite. They're going to lose heat. And when they lose heat, we call it exothermic. Exothermic is where something gets colder. So when there's a movement of heat back and forth, something's always going to be exo, it will lose heat energy, and something else will be endo, it gains heat energy. Energy has to go from one thing to another thing. You don't have heat energy suddenly being created out of thin air. You don't have it suddenly disappearing and going away randomly. So the thing that loses heat energy, we call it exothermic. It's releasing heat. So it's getting rid of its heat energy. It's losing some of that heat energy. And because of that, its temperature will go down. Its temperature is going to get colder. It's going to decrease. And we can think of exo like exit. It's going out. Or exoskeleton is a shell on the outside. Anything like that. But it means heat's going out. It's exiting. Energy is going down. Temperature is going down. The thing it gives energy to will absorb that heat energy, its temperature will go up, and it's then endothermic. But exo is losing heat, endo is gaining heat. So just one last point on that last thing. I always remember exo being like exit. I think that's probably easier to remember. If you have trouble remembering which is which, just focus on that one. Go with exo, sounds like exit, something's going out. The heat's going out. It's losing energy. It's going to get colder. And then endo is the opposite. If you can remember one, then you can just kind of fill in the blanks for the other one if you need to remember what endo is too. So last thing here before the bell and before I log this off, we've got two pictures here. In the first one, the arrows are going down. So in this picture on the left, the arrows are going and the heat's going down into the blue. It's gaining energy from the outside. So the blue liquid would be undergoing an endothermic process as it gains heat, whereas the surrounding room would be a little bit exo because it's losing heat and giving it to the blue liquid. In the picture on the right, the arrows are going out, the heat's going out. So the red liquid right here looks like it's going to be warmer than the surrounding room. So the warmer liquid is giving energy away. It's undergoing an exothermic change. It's losing heat energy. It's going to cool down a little bit. Whereas the room, which gains all this extra energy, that's going to be picking up extra heat. It'll go up with its temperature a little bit, and it would be endothermic. So if you're giving heat away from one perspective, your exothermic change and exothermic process. And from the other perspective, if you are now gaining that lost heat energy, you're picking up some extra heat, your temperature is going to go up and you're going to be endothermic. So that's the end of this. I kept it under 15 minutes. I was hoping to get a little bit shorter, but whatever. Make sure you now just go and finish off. This was lesson 2. So go to Schoology and finish the lesson 3.2 work. That's L 3.2 work in Schoology. Some questions, and we'll just relate to this stuff. And then on Monday, I'll have some other stuff to do, and we'll go from there. Have a great weekend. I'll see you in a couple of days.